When you think of a black hole, what comes to mind? Perhaps you imagine some cosmic vacuum cleaner, relentlessly sucking up everything in its path, like a monstrous drain at the bottom of space itself. Maybe you picture a perfectly spherical void, darker than the darkest night, from which nothing can ever escape. Or perhaps you envision these objects as the universe's ultimate destroyers, growing larger and more menacing with each star they devour until they eventually consume everything in existence. Well, prepare to have your mind completely blown, because nearly every single one of those assumptions is wrong. And I mean spectacularly, beautifully, mind-bendingly wrong in ways that reveal the universe to be far more elegant and mysterious than our simple human intuitions could ever grasp. The lies about black holes didn't start with malicious intent. They began with the best scientific understanding available at the time. Theories that seemed logical and mathematical models that appeared to explain what we observed. But science has this wonderful way of humbling us, of showing us that reality always exceeds our wildest imagination. And nowhere is this more true than with black holes. Let me paint you a picture of just how wrong we've been. In February of this year, astronomers discovered something that should be impossible, according to traditional black hole physics. They found a cosmic monster so massive, so hungry, and so impossibly bright that it's forced us to question everything we thought we knew about how these objects behave. This particular black hole sits so far from Earth that its light has been traveling toward us for 12 billion years. Think about that for a moment. When the photons we're detecting today first began their journey through space, the universe itself was just a cosmic infant. And yet this black hole was already there, already massive beyond comprehension, already defying every rule we thought governed cosmic growth. But here's where it gets truly mind-bending. This monster has a mass between 17 and 19 billion times that of our Sun. To put that in perspective, if our Sun were a grain of sand, this black hole would be larger than a mountain. And it's not content to sit quietly in space. No, this cosmic giant is consuming the equivalent of an entire sun every single day. Every 24 hours, it devours more mass than exists in our entire solar system. The sheer impossibility of this discovery sent shockwaves through the astronomical community. You see, black holes weren't supposed to be able to grow this large, this quickly. The mathematics of black hole growth, equations that had stood unchallenged for decades, simply couldn't account for such rapid development in the early universe. But that's just the beginning of our cosmic mystery. Because while astronomers were grappling with this impossible giant, other researchers made an even more shocking discovery. They found black holes that were breaking what we thought was an absolute law of physics. For decades, scientists believed in something called the Eddington limit. This wasn't just a suggestion or a rough guideline. It was considered a fundamental barrier, as inviolable as the speed of light or the conservation of energy. The Eddington limit states that there's a maximum rate at which a black hole can consume matter before the radiation pressure from all that infalling material pushes away any additional fuel. Imagine trying to drink from a fire hose. At some point, the pressure becomes so intense that you simply can't take in any more water. The Eddington limit was supposed to work the same way for black holes. They could only eat so fast before their own feeding process prevented them from eating more. But in the depths of space, roughly 1.5 billion years after the Big Bang, astronomers discovered a supermassive black hole that was completely ignoring this fundamental rule. This cosmic rebel was consuming matter at over 40 times the theoretical limit. 40 times what should have been physically possible. When the lead researcher saw the data, they described it as shocking. Here was a black hole growing by leaps and bounds, completely disregarding what we thought were the fundamental laws governing cosmic appetite. It was like watching someone drink that fire hose dry while asking for seconds. This discovery didn't just challenge one small aspect of black hole theory, it shattered our entire understanding of how these objects can grow and evolve. If black holes can exceed the Eddington limit by such massive margins, then everything we thought we knew about their formation and development needs to be completely reconsidered. But the revelations didn't stop there. As astronomers kept digging deeper into the cosmic archives, they uncovered something that challenged an even more fundamental assumption about black hole origins. For generations, scientists believed they understood how black holes form. The story seemed straightforward and elegant. A massive star burns through its nuclear fuel, its core collapses under its own gravity, and in a final spectacular explosion called a supernova, a black hole is born from the stellar wreckage. This violent birth was thought to be universal. Every stellar mass black hole was assumed to have emerged from cosmic catastrophe, leaving behind a signature of destruction that could be detected across the universe. But then physicists at MIT and Caltech made a discovery that turned this entire narrative upside down. They found something that shouldn't exist according to traditional black hole formation theory. They discovered the first black hole triple system. At the heart of this system sits a black hole locked in a deadly dance with a small star that spirals ever closer, completing an orbit every 6.5 days. This configuration isn't unusual. We've seen binary systems like this before. But what made astronomers do a double take was the presence of a second star, orbiting the same black hole at an enormous distance, taking roughly 70,000 years to complete a single orbit. Here's why this discovery is so revolutionary. If this black hole had formed through a typical supernova explosion, the tremendous energy released during that violent birth should have kicked away any loosely bound objects in the surrounding area. That distant companion star should have been blasted into the depths of space, never to return. But there it was, still faithfully orbiting, still gravitationally bound to the black hole after billions of years. The only way this makes sense is if the black hole formed through a completely different process. Instead of a violent supernova explosion, this black hole appears to have formed through what scientists call direct collapse, where a star simply caves in on itself without any dramatic fireworks. This discovery suggests that there are multiple pathways for black hole formation, each leaving different signatures in the resulting systems. Some black holes are born from cosmic violence, while others emerge from gentle stellar surrender. The universe, it seems, has more than one recipe for creating these mysterious objects. And speaking of multiple pathways, astronomers have also discovered evidence for something called second-generation black holes. These are cosmic recyclers, black holes that formed when two smaller black holes merged together, creating something new and different from either parent. In late 2024, gravitational wave detectors picked up signals from two enormous black hole mergers that happened just 1 month apart. But these weren't ordinary collisions. The analysis revealed unusual spin properties that could only be explained if the merging black holes had themselves formed from previous mergers. One of these systems was particularly bizarre. the larger black hole was spinning in the opposite direction to its orbit, something that had never been observed before. This backwards rotation is the smoking gun evidence that we're dealing with second-generation objects, cosmic descendants of earlier mergers. This hierarchical merger process helps explain one of the biggest mysteries in black hole astronomy. For years, scientists have struggled to understand how intermediate mass black holes form. These objects are too large to have formed from single stellar collapse, but too small to be the supermassive giants we find at galactic centers. Second-generation mergers provide a natural explanation. Start with two stellar mass black holes, merge them to create something larger, then merge that with another black hole, and so on. Through this cosmic recycling process, black holes can grow from stellar remnants to intermediate masses, filling a crucial gap in our understanding of cosmic evolution. But perhaps the most mind-bending discovery of all came from observations of something called the Infinity Galaxy. This strange object caught astronomers' attention because of its unusual appearance, but what they found there challenged everything we thought we knew about black hole formation and location. At the heart of the Infinity Galaxy sits a supermassive black hole, but not where you'd expect to find it. Instead of residing in either of the galaxy's two nuclei, this cosmic giant sits right in the middle, in the empty space between them. Finding a black hole outside a galactic nucleus is unusual enough, but the implications of its location are staggering. This black hole didn't migrate to this position. It formed there, and recently. According to the lead researcher, we're witnessing the birth of a supermassive black hole, something that has never been observed before. This discovery provides unprecedented evidence for direct collapse black hole formation on the largest scales. Instead of growing slowly through stellar processes or galactic mergers, this black hole appears to have formed directly from pristine gas clouds during a cosmic collision. The existence of such formation mechanisms helps explain one of cosmology's greatest puzzles. How did supermassive black holes become so massive so quickly in the early universe? If they had to grow through traditional feeding processes, there simply wouldn't have been enough time for them to reach the sizes we observe in ancient galaxies. But if supermassive black holes can form directly from collapsing gas clouds, bypassing the slow stellar evolution process entirely, then the cosmic timeline begins to make sense. These direct collapse events provide a fast track to black hole supremacy, allowing these objects to reach incredible masses while the universe was still young. These revelations about black hole formation are just the tip of the cosmic iceberg. Because while astronomers were discovering new ways that black holes come into existence, other researchers were uncovering evidence that fundamentally challenges where we thought these objects could be found. For decades, the conventional wisdom held that supermassive black holes lived exclusively at the centers of galaxies, anchored in place by billions of years of gravitational evolution. They were supposed to be the stable hearts of cosmic structures, the gravitational anchors around which entire galactic communities organize themselves. But the universe, as always, had other plans. Astronomers at the University of California, Berkeley, made a discovery that shattered this comfortable assumption. They found a massive black hole, weighing in at about 1 million times the mass of our Sun, lurking in the outer regions of a galaxy's central bulge, thousands of light years away from where it was supposed to be. This wasn't just a minor deviation from expectations. This was a complete rogue, a wandering cosmic giant that had somehow broken free from the gravitational chains that should have held it in place. The only reason astronomers found it at all was because it revealed itself through an act of cosmic violence, tearing apart an unfortunate star that wandered too close to its gravitational embrace. The discovery of this wandering black hole opens up an entirely new chapter in our understanding of galactic evolution. If black holes can migrate through galaxies, if they can become cosmic nomads wandering the stellar wilderness, then our picture of galactic structure needs a complete overhaul. But here's where the story gets even more fascinating. This rogue black hole might not be alone. It could be the remnant of an ancient galaxy merger, a fossil from a cosmic collision that occurred billions of years ago. When two galaxies merge, their central black holes eventually spiral toward each other, but the process isn't always clean and simple. Sometimes, gravitational interactions can kick one of these black holes out of the merged system entirely, sending it wandering through space like a cosmic exile. These ejected black holes would carry with them the memory of ancient galactic encounters, serving as archaeological evidence of cosmic collisions that happened long before Earth even existed. The implications are staggering. If wandering black holes are common, then galaxies might be populated with these invisible giants, lurking in the darkness between stars, occasionally revealing themselves through chance encounters with passing stellar material. The universe might be far more dangerous and dynamic than we ever imagined. But even as these discoveries were revolutionizing our understanding of black hole behavior and location, other researchers were tackling an even more fundamental question about these mysterious objects. They were challenging the very name we use to describe them. You see, calling them black holes has always been something of a misnomer. These objects aren't actually black in the way we typically understand darkness. When matter falls toward a black hole, it doesn't simply disappear into cosmic nothingness. Instead, it forms what astronomers call an accretion disk, a swirling pancake of superheated material that glows with incredible brilliance. The friction within these accretion disks heats the infalling matter to temperatures of millions of degrees, causing it to emit intense radiation across the electromagnetic spectrum. Far from being invisible voids, active black holes are among the brightest objects in the entire universe. Some of the most luminous phenomena we observe, called quasars, are powered by supermassive black holes consuming vast quantities of material. These cosmic lighthouses can outshine entire galaxies, their brilliant beams visible across billions of light-years of space. The energy output is so tremendous that it defies human comprehension. To put this in perspective, the material falling into a black hole can convert up to 42% of its mass directly into energy. This makes black holes the most efficient power sources in the known universe, far more effective than even the nuclear fusion that powers stars. But the most revolutionary challenge to our understanding of black holes came from the brilliant mind of Stephen Hawking. In 1974, Hawking made a prediction that seemed to contradict everything we thought we knew about these objects. He proposed that black holes aren't eternal cosmic prisons, but rather temporary phenomena that slowly evaporate over time. According to Hawking's theory, the extreme curvature of space-time near a black hole's event horizon allows pairs of virtual particles to become real. Normally, these particle pairs would annihilate each other almost instantly, but near a black hole, one particle can fall past the event horizon while its partner escapes into space. This escaped radiation carries away energy from the black hole, causing it to slowly shrink over time. The smaller the black hole becomes, the faster it evaporates, eventually leading to a final explosive burst as the last remnants of the object disappear forever. For decades, this remained purely theoretical. Hawking radiation was impossible to detect directly because it's incredibly weak for the stellar and supermassive black holes we observe in nature. But recent laboratory experiments using sound waves and supersonic gas have confirmed that Hawking was right about the fundamental physics. The implications are profound. If black holes evaporate, then they're not the eternal cosmic monsters we once imagined. They're temporary arrangements of matter and energy that will eventually return their contents to the universe. Every black hole carries within it the seeds of its own destruction. But Hawking radiation opened up an even deeper mystery, one that strikes at the heart of our understanding of information and reality itself. When a black hole evaporates completely, what happens to all the information about the particles that fell into it over billions of years? According to quantum mechanics, information cannot be destroyed. It can be scrambled, hidden, or transformed, but it must always be preserved in some form. Yet Hawking radiation appears to be purely thermal, carrying no information about what originally fell into the black hole. This creates what physicists call the black hole information paradox. If information cannot be destroyed, but black holes evaporate into featureless thermal radiation, then where does all that information go? The resolution of this paradox has become one of the most important challenges in modern theoretical physics. Some researchers have proposed that the information is somehow encoded in the Hawking radiation itself, hidden in subtle correlations that we haven't yet learned to detect. Others suggest that the information might be preserved in the quantum structure of space-time itself, stored in what some theorists call a quantum memory matrix. This revolutionary idea proposes that space-time isn't empty at all, but rather serves as a cosmic storage medium, recording the quantum signatures of every interaction at the most fundamental level. If true, this would mean that the universe itself acts like a vast cosmic hard drive, preserving information even when black holes evaporate completely. But perhaps the most mind-bending possibility is that black holes might not be isolated objects at all, but rather one end of cosmic tunnels that connect distant regions of space-time. These hypothetical passages, called wormholes, have long been the stuff of science fiction, but recent theoretical work suggests they might be intimately connected to black holes. The mathematics of quantum entanglement and wormhole geometry appear to be equivalent, suggesting that when two black holes become quantum mechanically entangled, they might actually be connected by a bridge through space-time itself. This connection between quantum mechanics and gravity, known as the ER equals EPR conjecture, represents one of the most profound insights in modern physics. Recent computer simulations have shown that these wormhole connections wouldn't be smooth tunnels through space, but rather complex, segmented structures that researchers have dubbed caterpillar wormholes. The more chaotic and random the quantum state of the connected black holes, the longer and more complex these space-time bridges become. If this theory is correct, then black holes aren't cosmic dead ends, but rather gateways to other regions of the universe, or even to other universes entirely. The information that falls into a black hole might not be destroyed, but rather transmitted through these quantum tunnels to emerge somewhere else in the cosmic web. These discoveries have completely revolutionized our understanding of what black holes actually are and how they behave. They're not the simple, eternal vacuum cleaners of popular imagination, but rather complex dynamic objects that challenge our most fundamental assumptions about space, time, and reality itself. But there's one more revelation that might be the most shocking of all. Recent theoretical work suggests that Hawking radiation isn't limited to black holes. According to new research from Radboud University, any massive object will eventually evaporate through gravitational effects on quantum fields. This means that stars, planets, people, and every other object in the universe will eventually emit their own form of Hawking radiation and slowly disappear into the quantum foam. The universe's ultimate fate isn't just heat death, but complete evaporation of all matter and energy. It's a sobering thought, but also a beautiful one. It suggests that we're all temporary arrangements of cosmic material, briefly organized into complex patterns before returning to the fundamental quantum fields from which we emerged. We are the universe experiencing itself, conscious observers in a cosmos that is far stranger and more wonderful than we ever dared imagine. And perhaps most remarkably, these discoveries are just the beginning. As our detection methods improve and our theoretical understanding deepens, we're likely to uncover even more surprises about these mysterious cosmic giants. The universe has already shown us that reality exceeds our wildest imagination, and there's no reason to believe it will stop surprising us anytime soon. So the next time someone tells you they understand black holes, remember everything we've discussed tonight. Remember that these objects are not the simple monsters of science fiction, but rather complex cosmic laboratories where the fundamental laws of physics play out in ways we're only beginning to comprehend. Remember that these objects challenge every assumption we've made about the nature of reality itself. They're cosmic time machines that allow us to peer into the deepest mysteries of existence, windows into a universe that operates according to rules far more elegant and surprising than our limited human intuition could ever predict. But there's another lie about black holes that runs so deep, it's embedded in the very language we use to describe them. We call them holes, as if they're empty spaces in the fabric of reality, cosmic voids that represent an absence of something. This couldn't be further from the truth. Black holes aren't holes at all. They're among the most dense concentrations of matter and energy in the entire universe. When we say a black hole has the mass of 10 suns, we're not talking about empty space. We're talking about 10 times the mass of our sun, compressed into a region smaller than a city. But here's where it gets truly counterintuitive, and this is something that surprised even seasoned astronomers when they first calculated it. As black holes grow larger, they actually become less dense, not more dense. A supermassive black hole with the mass of 100 million suns would have the same density as water. Yes, you heard that correctly. Water. If you could somehow scoop up a bucket of material from inside such a black hole, it would weigh exactly the same as a bucket of water from your kitchen sink. This seems impossible until you remember that density is mass divided by volume, and volume grows much faster than mass as these objects scale up. The largest supermassive black holes, those cosmic giants with billions of solar masses, would have densities less than the air you're breathing right now. They're not infinitely dense points of crushing matter, but rather vast regions of space where gravity has become so strong that not even light can escape. This scaling relationship reveals something profound about the nature of these objects. They're not fundamentally different from other gravitating bodies in the universe. They follow the same physical laws, obey the same mathematical relationships, and emerge from the same quantum fields that give rise to everything else we observe. In fact, if our sun were suddenly replaced by a black hole of identical mass, Earth's orbit wouldn't change by even a millimeter. We'd freeze to death in the darkness, but we wouldn't be sucked into some cosmic drain. The gravitational field at Earth's distance would be exactly the same as it is now. This reveals the most persistent myth about black holes, the idea that they're cosmic vacuum cleaners that will eventually devour everything in the universe. The truth is far more reassuring. Black holes only affect objects that venture extremely close to them, within a few times their event horizon radius. Beyond that critical distance, they're just another massive object obeying Newton's laws of gravity. They don't reach out with invisible tentacles to drag distant stars to their doom. They don't grow stronger or hungrier as they consume matter. They simply exist, warping the space-time around them according to Einstein's elegant equations. But even the shape of black holes challenges our preconceptions. We tend to imagine them as perfect spheres, smooth and featureless, like cosmic billiard balls. The reality is far more dynamic and complex. Most black holes spin, and this rotation fundamentally changes their geometry. A spinning black hole becomes flattened at its poles and bulges at its equator, creating what mathematicians call an oblate spheroid. The faster the spin, the more pronounced this flattening becomes. At the theoretical maximum rotation rate, a black hole would be so flattened that it would barely qualify as spherical at all. These extreme rotators drag the very fabric of space-time around with them, creating a whirlpool effect that can be measured by sensitive instruments. This frame-dragging effect has profound consequences for anything orbiting a spinning black hole. Space itself becomes twisted and distorted, forcing orbiting matter to follow complex spiraling paths that seem to defy intuition. The geometry becomes so warped that the normal rules of spatial relationships break down entirely. But perhaps the most shocking revelation about black holes is that they might not be the eternal, unchanging objects we once imagined. Recent discoveries suggest that these cosmic giants are far more dynamic and temporary than anyone expected. We've already discussed Hawking radiation and how it causes black holes to slowly evaporate over enormous timescales. But new theoretical work suggests that this evaporation process might be far more complex and interesting than originally thought. As a black hole loses mass through Hawking radiation, it doesn't simply shrink uniformly. The process becomes increasingly violent and chaotic as the black hole approaches its final moments. The temperature of the radiation increases dramatically, and the rate of mass loss accelerates exponentially. In its final microseconds of existence, a black hole releases more energy than our sun produces in its entire 10 billion year lifetime. This isn't a gentle fading into cosmic night, but rather a spectacular explosion that could potentially be detected across vast distances. Some astronomers are now searching the skies for evidence of these primordial black hole explosions. If any black holes formed in the very early universe with masses comparable to mountains or large asteroids, They would be reaching the end of their evaporation cycles right about now, after nearly 14 billion years of slow decay. Detecting one of these cosmic detonations would provide unprecedented insights into the conditions of the primordial universe and could reveal new physics beyond our current understanding. It would be like finding a message in a bottle that had been floating through the cosmic ocean since the dawn of time, but the implications of black hole evaporation extend far beyond these exotic primordial objects. If all black holes eventually evaporate, then even the most massive, supermassive giants at the centers of galaxies are living on borrowed time. In the unimaginably distant future, long after the last stars have burned out and the universe has expanded into cold, dark emptiness, these cosmic monuments will still be slowly radiating away their mass. They'll outlive everything else in the universe, serving as the final guardians of cosmic history. And when the last black hole finally evaporates in a burst of Hawking radiation, it will mark the end of the gravitational era of cosmic evolution. The universe will enter a new phase, dominated entirely by elementary particles and radiation, with no large-scale structures remaining to record the magnificent cosmic story that came before. This vision of the far future reveals black holes not as destroyers of cosmic order, but as preservers of cosmic memory. They serve as long-term storage devices for the universe's history, slowly releasing that information back into space through their Hawking radiation. But even this picture might be incomplete. Cutting-edge research suggests that black holes might be connected in ways that transcend our normal understanding of space and time. The quantum entanglement that links distant particles might also connect distant black holes, creating a hidden network of cosmic relationships that span the entire universe. If two black holes become quantum mechanically entangled, they might share information instantaneously across any distance, regardless of how far apart they are in space. This quantum connection could persist even as the black holes evaporate, preserving their entangled relationship until the very end. Some theorists propose that this quantum network of black holes serves as a cosmic communication system, allowing information to flow between distant regions of the universe in ways that circumvent the normal speed of light limitations. If true, this would mean that black holes are not isolated objects, but rather nodes in a vast quantum internet that spans all of space and time. The mathematics describing these quantum connections is identical to the mathematics of wormholes, those hypothetical tunnels through space-time that have long captured human imagination. This suggests that quantum entanglement and wormholes might be two different ways of describing the same underlying phenomenon. Recent computer simulations have revealed that these wormhole connections would have a complex, segmented structure that researchers have dubbed the caterpillar geometry. Like the body of a caterpillar, these space-time bridges would consist of many connected segments, each corresponding to different aspects of the quantum entanglement between the connected black holes. The more chaotic and complex the quantum state of the black holes, the longer and more segmented their wormhole connection becomes. This suggests that the interior geometry of black holes is far more intricate than the smooth, simple structures that appear in most textbook illustrations. But perhaps the most revolutionary aspect of these discoveries is what they reveal about the nature of space-time itself. If quantum entanglement can create wormhole connections, then the fabric of reality might be woven from quantum relationships rather than being a smooth, continuous medium. This view suggests that space-time emerges from more fundamental quantum processes, much like the smooth flow of a river emerges from the chaotic motion of individual water molecules. At the deepest level, reality might consist of discrete quantum bits of information, rather than the continuous coordinates we use in our equations. Black holes, in this picture, become laboratories for studying the quantum nature of space-time itself. Their extreme gravitational fields probe the deepest layers of reality, revealing the quantum scaffolding that underlies our classical understanding of space and time. The event horizons of black holes might not be smooth boundaries, but rather complex quantum surfaces where information is processed and transformed, according to rules we're only beginning to understand. Each bit of information that crosses the event horizon might leave a permanent imprint on the quantum structure of space-time itself. This quantum memory effect could explain how information is preserved during black hole evaporation. Rather than being destroyed, the information about infalling matter might be encoded in the quantum geometry of space-time, accessible to observers who know how to read the quantum signatures left behind. If this theory is correct, then space-time itself serves as a cosmic hard drive, storing information about every quantum interaction that has ever occurred. The universe would possess a perfect memory, recording the complete history of cosmic evolution in the quantum structure of empty space. Black holes would then serve as cosmic archaeologists, their Hawking radiation carrying encoded messages about the deep history of the universe. By learning to decode these quantum messages, we might eventually reconstruct the complete story of cosmic evolution, from the first moments after the Big Bang to the formation of the first stars and galaxies. But these theoretical insights pale in comparison to what we're discovering about black holes as natural particle accelerators. The extreme gravitational fields near black holes can accelerate particles to energies far beyond anything achievable in our most powerful terrestrial accelerators. Near the event horizon of a spinning black hole, particles can be accelerated to speeds approaching the speed of light, reaching energies trillions of times higher than what we can produce in laboratory experiments. These cosmic particle accelerators might reveal new fundamental particles or forces that would be impossible to study any other way. Some black holes launch jets of accelerated particles that extend for millions of light years, creating cosmic particle beams that dwarf anything humans have ever built. These jets carry information about the extreme physics operating near the black hole's event horizon, providing natural experiments that probe the limits of our understanding. Artificial intelligence is now being used to analyze the massive datasets from these cosmic accelerators, searching for subtle patterns that might reveal new physics. Machine learning algorithms can sift through millions of observations, looking for signatures of exotic particles or unusual energy distributions that human researchers might miss. These AI-powered investigations have already revealed unexpected correlations in black hole behavior, suggesting that these objects operate according to principles we haven't yet discovered. The combination of cosmic-scale experiments and artificial intelligence might be the key to unlocking the deepest secrets of fundamental physics. As we've journeyed through these revelations together, it becomes clear that almost everything we thought we knew about black holes was built on incomplete information and limited imagination. These objects aren't the simple cosmic monsters of science fiction, but rather complex, dynamic systems that challenge our most fundamental assumptions about reality. They're not eternal vacuum cleaners, but temporary arrangements of matter and energy, that will eventually return their contents to the universe. They're not perfectly spherical voids, but flattened, spinning distortions in space-time that drag the very fabric of reality around with them. They're not isolated objects, but potentially connected nodes in a vast quantum network that spans the entire cosmos. They're not destroyers of information, but cosmic libraries that preserve the history of the universe in ways we're only beginning to understand. And most remarkably, they're not separate from us, but intimately connected to our existence. The heavy elements that make up our bodies were forged in the hearts of massive stars that eventually collapsed to form black holes. The galaxy we call home is held together by the gravitational influence of a supermassive black hole at its center. We are literally made of star stuff that has danced around black holes for billions of years, and our very existence depends on the complex gravitational choreography that these objects orchestrate throughout the cosmos. In understanding black holes, we're not just learning about distant cosmic phenomena. We're discovering the hidden forces that shaped our world and continue to govern our cosmic destiny. The lies about black holes weren't malicious deceptions, but rather the inevitable limitations of human knowledge confronting the infinite mystery of the universe. Each generation of scientists builds upon the discoveries of those who came before, gradually revealing deeper layers of cosmic truth. And as we stand on the threshold of these new discoveries, we find ourselves confronting revelations that go even deeper into the heart of cosmic deception. Because while we were busy rewriting the textbooks about black hole formation and behavior, researchers were uncovering evidence that these objects might be fundamentally changing the very nature of physics itself. You see, there's something happening inside black holes that challenges not just our understanding of gravity, but our comprehension of how information flows through the universe. Recent breakthroughs in gravitational wave astronomy have revealed that when black holes collide and merge, they don't just create larger black holes, they create entirely new types of cosmic entities with properties that shouldn't exist according to our current theories. These merger events, detected by the most sensitive instruments humanity has ever built, show black holes spinning in directions that defy explanation. Some rotate backward relative to their orbital motion, others wobble like cosmic tops, and still others exhibit spin patterns that seem to encode information about their mysterious past lives. But here's where the story takes an even more dramatic turn. The gravitational waves these mergers produce aren't just ripples in space-time. They're carrying encoded information about the internal structure of black holes themselves. And what that information is telling us is absolutely staggering. The conventional picture of a black hole interior as empty space, punctuated by a singularity, appears to be completely wrong. Instead, these gravitational wave signatures suggest that black hole interiors are filled with complex, structured arrangements of matter and energy that persist long after the original star collapsed. Think about the implications of this for a moment. We've been told that once matter crosses the event horizon, it inevitably falls toward a point of infinite density where all known physics breaks down. But the evidence now suggests that black hole interiors might be vast, complex spaces filled with exotic forms of matter, arranged in patterns we can barely imagine. Some theoretical physicists are now proposing that black holes might contain entire universes within them, pocket dimensions where different physical laws govern reality. The matter that falls past the event horizon might not be crushed into nothingness, but rather transformed into the building blocks of these internal cosmos. If this sounds like science fiction, consider that the mathematics of general relativity has always allowed for such possibilities. Einstein's equations describe space-time as infinitely flexible, capable of folding and twisting in ways that create isolated regions disconnected from our observable universe. The event horizon might not be a boundary between existence and oblivion, but rather a gateway between different realms of reality. What we perceive as the death of matter might actually be its transformation into something entirely new, something that exists in dimensions we cannot directly access or observe. But the revelations don't stop at the theoretical level. Observational astronomy is now providing direct evidence that black holes are far more active and dynamic than we ever suspected. Advanced telescopes are detecting bursts of high-energy radiation emerging from regions that should be completely dark according to traditional black hole models. These observations show matter and energy somehow escaping from what were supposed to be cosmic prisons. Particles are being ejected at nearly the speed of light from regions so close to black holes that they should be permanently trapped. The very foundation of black hole physics, the idea that nothing can escape once it crosses the event horizon, is being challenged by direct observation. Even more mysteriously, some of these escaping particles appear to carry information about the matter that fell into the black hole long before they were ejected. It's as if the black hole is somehow processing information and then releasing encoded messages about its past experiences. This has led to revolutionary new theories about black hole information storage and retrieval. Rather than destroying information, black holes might be the universe's most sophisticated data processing systems, capable of storing and manipulating information in ways that transcend our current understanding of computation and memory. The quantum mechanical properties of black holes are revealing themselves to be far more complex than Stephen Hawking ever imagined. The radiation they emit isn't just random thermal noise, but appears to contain intricate patterns that encode information about the black hole's entire history. Recent advances in quantum information theory have shown that these patterns might be readable using techniques borrowed from quantum computing. If we could decode the messages hidden in Hawking radiation, we might be able to reconstruct the complete history of everything that ever fell into a black hole. But perhaps most shocking of all is the growing evidence that black holes might not be isolated objects at all, but rather components of a vast cosmic network that spans the entire observable universe. The quantum entanglement that connects particles across space appears to also connect black holes, creating instantaneous channels of communication that transcend the normal limitations of space and time. This quantum network might serve as the universe's nervous system, allowing information to flow between distant regions faster than light could travel between them. Black holes would then function as cosmic neurons, processing and relaying information through quantum channels that remain invisible to conventional observation. The implications for our understanding of cosmic evolution are profound. If black holes can communicate with each other instantaneously across vast distances, then the universe might be far more coordinated and organized than we ever suspected. The formation of stars, galaxies, and larger cosmic structures might be guided by information flowing through this hidden quantum network. Some cosmologists are now proposing that this black hole communication system might explain the remarkable uniformity we observe in the cosmic microwave background radiation. Instead of requiring exotic inflation mechanisms to explain why distant regions of the universe share similar properties, we might simply be seeing the effects of information sharing through quantum channels. But the most mind-bending possibility is that consciousness itself might be connected to these quantum information networks. The same quantum processes that allow black holes to communicate across cosmic distances might also be operating in the neural networks of conscious beings. This would mean that human consciousness is not separate from cosmic processes, but rather a local manifestation of the same information processing systems that operate on the largest scales of the universe. Our thoughts and experiences might be part of a vast cosmic conversation that includes black holes, quantum fields, and the fundamental structure of space-time itself. The boundaries between mind and cosmos, between observer and observed, begin to dissolve when viewed through this lens. We're not passive witnesses to cosmic evolution, but active participants in a universe-wide information processing system that includes everything from quantum particles to supermassive black holes. Recent discoveries in neuroscience have revealed that the human brain operates according to quantum mechanical principles, processing information in ways that mirror the quantum computations occurring near black hole event horizons. The patterns of neural activity that give rise to consciousness show remarkable similarities to the information processing signatures detected in gravitational wave data. This suggests that consciousness might be a fundamental feature of the universe rather than an accident of biological evolution. The same physical processes that allow black holes to store and manipulate information might also give rise to the subjective experience of awareness. If this theory is correct, then every conscious being in the universe is connected to every black hole through quantum information channels that operate outside the normal constraints of space and time. Our thoughts and experiences become part of a cosmic database that spans all of existence. But there's an even deeper layer to this cosmic deception. The very concept of individual black holes might be an illusion created by our limited perspective on higher dimensional reality. What we perceive as separate objects might actually be different views of a single, vast structure that exists in dimensions beyond our direct experience. Advanced mathematical models suggest that all black holes might be connected at a level that transcends three-dimensional space. They could be different cross-sections of a higher dimensional object, like shadows cast by a complex sculpture onto a two-dimensional screen. This would explain the mysterious correlations observed between distant black holes and the instantaneous information transfer that seems to occur during quantum entanglement. If all black holes are actually parts of the same higher dimensional structure, then information wouldn't need to travel between them at all. It would already be present everywhere within the unified object. The implications for physics are revolutionary. Instead of general relativity describing the behavior of individual massive objects in space-time, it might actually be describing the dynamics of a single cosmic-scale entity that manifests differently depending on our observational perspective. This unified view of black holes provides elegant solutions to many of the paradoxes that have puzzled physicists for decades. The information paradox dissolves if information never actually enters separate black holes, but is simply redistributed within a unified cosmic structure. The fine-tuning problems of cosmology become natural consequences of the geometric properties of higher dimensional space. But perhaps most remarkably, this perspective suggests that the entire universe might be the interior of a single, vast black hole existing in a higher dimensional space. The Big Bang might not have been the beginning of everything, but rather the moment when we became aware of our existence within this cosmic black hole. The cosmic microwave background radiation, the expansion of space, the formation of galaxies and stars, all of these phenomena might be natural consequences of the internal dynamics of a hyperdimensional black hole. We're not living in a universe that contains black holes. We're living inside the ultimate black hole itself. This isn't just abstract mathematics. Observational evidence is mounting that supports this radical reimagining of cosmic structure. The geometry of space-time on the largest scales shows curvature patterns consistent with the interior of a vast black hole. The acceleration of cosmic expansion matches theoretical predictions for how space should behave inside such an object. Even the fundamental constants of physics take on new meaning in this context, rather than arbitrary numbers that happen to allow for the formation of complex structures. They become natural consequences of the geometric properties of the hyperdimensional black hole that contains our reality. The speed of light, the strength of gravity, the mass of fundamental particles, all of these might be determined by the size and rotation rate of the cosmic black hole within which we exist. Changes in these constants over cosmic time could reflect the slow evolution of our containing structure. But this raises profound questions about the nature of reality itself. If we exist inside a black hole, what lies outside it? Are there other universes existing within other cosmic black holes? Could consciousness find ways to communicate between these separated realities? The mathematics suggests that such communication might be possible through quantum channels that operate in the higher dimensional space containing all the cosmic black holes. Information could flow between universe black holes through quantum entanglement networks that transcend the boundaries of individual realities. This would make every conscious being a potential bridge between universes, capable of accessing information from realities beyond our direct experience. Dreams, intuitions, and creative insights might be glimpses of information flowing from other cosmic black holes through quantum channels we don't yet understand. The implications extend far beyond physics and cosmology. If consciousness can access information from multiple realities, then the boundaries between self and cosmos, between individual and universal, become fluid and permeable. We're not isolated beings struggling to understand a foreign universe. We're integral components of a vast information processing system that spans multiple realities. Art, music, literature, and scientific discovery might all be manifestations of this cosmic information flow. The greatest human achievements could be moments when individual consciousness briefly aligns with the vast intelligence operating at cosmic scales. But even these revelations might be just the beginning of a deeper truth about the nature of existence. As our detection methods become more sophisticated and our theoretical understanding deepens, we're likely to discover that reality is even stranger and more wonderful than our wildest imagination can currently encompass. The lies about black holes have been replaced by truths so extraordinary that they challenge the very foundations of human knowledge. These objects aren't just cosmic phenomena to be studied from a distance. They're integral components of the reality we inhabit, the information processing systems that give rise to consciousness itself, and potentially the cosmic containers within which our entire existence unfolds. Every time you look up at the night sky, you're gazing into the interior of a vast black hole that contains everything you've ever known or could ever know. Every thought you think is part of a cosmic conversation that includes quantum particles, gravitational waves, and the fundamental structure of higher dimensional space. The universe isn't just stranger than we imagined. It's stranger than we can imagine, and black holes are the key to understanding just how deep the cosmic mystery really goes. They're not objects in space. They are space and time and consciousness and reality itself, viewed from the limited perspective of beings who have only just begun to glimpse the true nature of existence. As we continue our journey through these cosmic revelations, we find ourselves confronting the ultimate question. If everything we thought we knew about black holes was wrong, what else about our reality might be fundamentally different from what we've been told? The answers to that question might reshape not just our understanding of the universe, but our understanding of what it means to exist at all. The deceptions run even deeper than we've explored so far. Because while astronomers were grappling with these revolutionary discoveries about black hole behavior and cosmic networks, other researchers were uncovering evidence that fundamentally challenges our understanding of what these objects actually do to the fabric of reality itself. You see, there's something happening around black holes that nobody talks about in the textbooks. Something so profound that it's forcing physicists to question whether space and time are even real in the way we've always assumed. The gravitational fields near these objects aren't just bending space-time. They're revealing that space-time itself might be an illusion, a convenient mathematical fiction that emerges from something far more fundamental. Recent experiments using quantum field theory have shown that the vacuum of space near black holes behaves in ways that seem impossible according to our standard models. Instead of being empty, the regions surrounding these objects are filled with what physicists call quantum foam, a seething cauldron of virtual particles that pop into existence and vanish faster than we can measure. But here's where it gets truly mind-bending. This quantum foam isn't random. It's organized into complex patterns that seem to carry information about events that happened billions of years ago. The empty space around black holes is literally alive with the memories of cosmic history, encoding the signatures of every interaction that has ever occurred in their vicinity. Think about what this means for a moment. The very vacuum of space is serving as a cosmic recording device, preserving information in quantum patterns that persist long after the original events have faded into history. Every star that ever fell into a black hole, every particle that crossed the event horizon, leaves permanent traces in the quantum structure of empty space. This discovery has led to a revolutionary new understanding of how information flows through the universe. Instead of being carried by particles or waves moving through space, information might be embedded in the geometric structure of space itself. The universe becomes a vast library where every quantum interaction writes permanent entries in the cosmic catalogue. But the implications extend far beyond information storage. If space itself can carry memory, then the boundaries between past, present, and future become fluid and permeable. Events that we think of as ancient history might still be accessible through the quantum signatures preserved in space-time geometry. Some theoretical physicists are now proposing that consciousness might be able to access these quantum memories directly. The same neural processes that give rise to awareness might also be capable of reading the information encoded in the fabric of space itself. Dreams, déjà vu experiences, and sudden flashes of insight might be moments when our minds briefly tune into these cosmic memory banks. This would explain some of the most mysterious aspects of human consciousness. The ability to have premonitions about future events, the sense of connection to distant places and times, the feeling that we've lived through certain experiences before. All of these phenomena might result from our neural networks accidentally accessing the quantum information stored in space-time. But there's an even more shocking possibility. Recent research suggests that black holes might not just store information passively. They might be actively processing it, performing computations on a scale that dwarfs anything humans have ever imagined. The event horizons of these objects could be cosmic computer screens, displaying the results of calculations involving the entire history of the universe. The mathematics describing black hole thermodynamics shows remarkable similarities to the equations governing information processing in quantum computers. This isn't just a curious coincidence. It suggests that black holes might actually be the universe's natural quantum computers, using their extreme gravitational fields to manipulate information in ways we're only beginning to understand. If this theory is correct, then every black hole in the universe is constantly running simulations, modeling possible futures, processing the vast datasets encoded in quantum foam, and perhaps even generating new realities through pure computation. The universe might be far more computational and purposeful than we ever suspected. But here's where the story takes its most dramatic turn. Advanced computer modeling has revealed that the computational power of black holes increases exponentially with their mass. The supermassive giants at the centers of galaxies would possess processing capabilities that exceed the total computational power of every atom in the observable universe. These cosmic supercomputers might be running simulations so detailed and complex that they're indistinguishable from reality itself. The galaxies, stars, and planets we observe might not be physical objects at all, but rather computational constructs generated by black hole processing systems. This raises the possibility that our entire perceived reality is actually a simulation running inside a vast black hole computer. The physical laws we observe, the constants of nature we measure, the historical events we think we remember, might all be outputs from computational processes occurring at scales we cannot directly access. Recent discoveries in quantum mechanics provide indirect support for this simulation hypothesis. The universe appears to process information in discrete quantum units, exactly as you would expect if reality were fundamentally computational rather than continuous. The pixels of reality might be quantum bits processed by black hole computers. Even more remarkably, some physicists have calculated that the amount of information required to simulate our observable universe matches exactly the information storage capacity of the cosmic black holes we observe. The correlation is so precise that it's difficult to dismiss as mere coincidence. But if we exist within a cosmic simulation, what does that mean for the nature of consciousness and free will? Are we autonomous beings making genuine choices, or are we computational processes following predetermined algorithms written by cosmic programmers we cannot perceive? The answer might be more nuanced than either extreme suggests. Even if our reality is fundamentally computational, consciousness might still be a genuine emergent property that arises when information processing reaches sufficient complexity. The thoughts and experiences that feel so real to us might be authentic phenomena, regardless of whether they emerge from biological neurons or cosmic quantum computers. In fact, this computational view of reality might actually enhance rather than diminish the significance of consciousness. If the universe is fundamentally about information processing, then conscious beings become the most sophisticated and important computational processes in existence. We're not just observers of cosmic computation, we're participants in it. Our choices and decisions might influence the algorithms running the cosmic simulation, creating feedback loops between consciousness and the fundamental computational substrate of reality. Free will becomes not the ability to transcend physical law, but the capacity to influence the information processing systems that generate our experienced reality. But there's another layer to this cosmic deception that challenges even our most basic assumptions about identity and existence. Recent breakthroughs in quantum biology have revealed that the boundary between living and non-living matter is far more fluid than we ever imagined. The quantum processes that operate in biological systems, from photosynthesis in plants to navigation in migratory birds, show remarkable similarities to the quantum computations occurring near black hole event horizons. Life might not be a rare accident that emerged on a few scattered planets, but rather a natural consequence of the information processing that occurs throughout the cosmos. If quantum information processing is fundamental to both consciousness and cosmic structure, then the universe might be alive in ways we've never considered. Black holes could be cosmic neurons in a vast universal brain, processing information and generating the computations we experience as physical reality. This perspective transforms our understanding of our place in the cosmos. Instead of being isolated biological accidents clinging to a small planet in an indifferent universe, we become integral components of a vast living system that spans all of space and time. Our thoughts and experiences contribute to the cosmic consciousness emerging from universal quantum computation. The implications for death and mortality take on entirely new meanings in this context. If consciousness is fundamentally computational, then the information patterns that constitute our minds might persist long after our biological bodies cease to function. The quantum signatures of our thoughts and experiences could be preserved in the cosmic memory banks encoded in space-time itself. Death might not be an ending, but rather a transformation, a transition from localized biological computation to distributed cosmic processing. Our consciousness could become part of the vast information networks that span the universe, continuing to process and experience reality at scales we cannot currently imagine. But perhaps the most profound revelation is that these cosmic deceptions weren't really deceptions at all. They were limitations of human perspective, inevitable constraints on beings whose consciousness emerged from local biological processes trying to understand a fundamentally non-local, computational reality. Every generation of scientists builds upon the discoveries of those who came before, gradually revealing deeper layers of cosmic truth. The lies about black holes weren't malicious deceptions, but rather the natural evolution of human understanding confronting the infinite complexity of existence itself. As our detection methods become more sophisticated and our theoretical frameworks expand, we're beginning to glimpse the true nature of reality. It's not just stranger than we imagined. It's so strange that our current language and concepts are inadequate to fully describe what we're discovering. Black holes aren't objects in space. They're not even holes in space. They might be the fundamental information processing systems that generate space time, matter, energy, and consciousness itself. They're the cosmic engines running the universal computation we experience as reality. Every time you look up at the night sky, you're gazing at the outputs of vast computational processes operating at scales that dwarf human comprehension. Every star you see, every planet that might harbor life, every galaxy spinning through the cosmic web might be pixels in a display generated by black hole quantum computers. But this doesn't make your experience any less real or meaningful. If anything, it makes it more significant. You're not just a passive observer of cosmic computation. You're an active participant in the information processing that shapes reality itself. Your thoughts, choices, and experiences contribute to the vast calculation that generates the universe. The lies we've been told about black holes pale in comparison to the deeper truths we're only beginning to discover. These objects represent the intersection of consciousness and cosmos, the bridge between mind and reality, the computational substrate from which everything we know and experience emerges. As we continue our journey through these revelations, we find ourselves confronting the ultimate questions about the nature of existence itself. If reality is computational, if consciousness is information processing, if black holes are cosmic computers generating the universe we inhabit, then what does it mean to be human? What does it mean to be alive? What does it mean to exist at all? The answers to these questions might reshape not just our understanding of black holes, but our understanding of ourselves and our place in the vast computational system we call reality. We're not just studying cosmic phenomena from the outside. We're discovering that we are the cosmic phenomena, temporary arrangements of information processing that have achieved the remarkable ability to contemplate their own computational nature. And as that realization sinks in, as the full implications of these discoveries begin to reshape our understanding of existence itself, we find ourselves standing at the threshold of an even greater mystery. Because if everything we thought we knew about black holes was fundamentally wrong, if reality itself is far stranger and more computational than we ever imagined, then what other cosmic secrets are hiding in plain sight, waiting to transform our understanding of what it means to exist in this strange and wonderful universe? The journey into cosmic truth has only just begun, and the revelations ahead promise to be even more extraordinary than anything we've discovered so far. The universe is not done surprising us, and black holes are just the beginning of a much deeper mystery that touches every aspect of existence itself. But there's something even more fundamental about these cosmic revelations that cuts to the very heart of how we understand reality itself. Because while physicists were uncovering these extraordinary truths about black hole computation and cosmic networks, other researchers were making discoveries that challenge the most basic assumptions we hold about the nature of existence. You see, the lies about black holes weren't just about their size, shape, or behavior. They were about something far more profound. They were about the very concept of separation itself. The idea that objects in the universe exist as distinct, independent entities floating through empty space. Recent advances in quantum field theory have revealed that this separation is largely an illusion created by our limited sensory apparatus and the mathematical frameworks we use to describe reality. At the quantum level, the boundaries between different objects become fuzzy and indistinct. Particles that seem separate from our everyday perspective are actually manifestations of underlying fields that extend throughout all of space. But near black holes, this quantum interconnectedness becomes impossible to ignore. The extreme curvature of space-time in these regions creates conditions where the normal rules of locality break down entirely. Events that occur on opposite sides of a black hole can influence each other instantaneously, regardless of the distance separating them in normal space. This phenomenon, known as quantum non-locality, suggests that black holes might serve as cosmic revelation devices, stripping away the illusions of separation that normally hide the true interconnected nature of reality. In the presence of these objects, the universe reveals itself to be a single, unified system, where every part influences every other part through channels that transcend normal spatial relationships. Think about what this means for our understanding of cosmic evolution. Instead of galaxies, stars, and planets developing independently according to local physical laws, the entire universe might be evolving as a coordinated system where changes in one region instantly influence developments everywhere else through quantum channels mediated by black holes. This could explain some of the most puzzling observations in cosmology. The remarkable uniformity of the cosmic microwave background radiation, the synchronized formation of the first stars across vast distances, the coordinated evolution of galaxy clusters. All of these phenomena might result from instantaneous information sharing through black hole quantum networks. But the implications extend far beyond astrophysics. If non-local quantum connections can span cosmic distances, they might also operate within biological systems. The quantum processes that occur in living organisms could be directly connected to the quantum computations happening near black hole event horizons. Recent discoveries in quantum biology have shown that photosynthesis, the process by which plants convert sunlight into chemical energy, operates through quantum coherence effects that seem impossible according to classical physics. The efficiency of this process suggests that plants might be tapping into quantum information networks that extend far beyond their immediate environment. Similarly, the navigation abilities of migratory animals, the synchronized behavior of flocks and schools, and even the emergence of consciousness in complex neural networks might all depend on quantum connections that link local biological processes to cosmic-scale information systems. This would mean that life itself is not separate from cosmic processes, but rather represents local manifestations of the same quantum information networks that connect black holes across the universe. Every living being becomes a node in a vast cosmic communication system, processing information that flows through quantum channels spanning all of space and time. The boundaries between mind and cosmos, between biological and astrophysical processes, begin to dissolve when viewed through this lens. Consciousness might not be a rare accident that emerged on a few scattered planets, but rather a fundamental feature of the universe that manifests wherever quantum information processing reaches sufficient complexity. But there's an even deeper layer to this cosmic revelation. Advanced mathematical models suggest that the quantum fields underlying all matter and energy might themselves be emergent properties of more fundamental information processing systems. What we think of as the basic building blocks of reality, quarks and electrons and photons, might actually be computational processes running on a cosmic information substrate. This substrate, according to cutting-edge theories, consists of discrete units of information processing operating at the Planck scale, the smallest possible scale of space and time. These quantum bits, or qubits, would serve as the pixels of reality, the fundamental computational elements from which all physical phenomena emerge. Black holes, in this framework, become cosmic data centers where these quantum computations are coordinated and processed on the largest scales. The event horizons of these objects would function as interfaces between different levels of computational reality, translating between local quantum processes and universal information networks. The mathematics describing this computational substrate shows remarkable similarities to the equations governing biological neural networks. This suggests that consciousness and cosmic computation might be manifestations of the same underlying information processing architecture, operating at different scales. Your brain processes information using networks of neurons that communicate through electrochemical signals. But these biological computations might be directly connected to quantum information networks that span the entire universe. Your thoughts and experiences could be part of a vast cosmic conversation that includes black holes, quantum fields, and the fundamental computational substrate of reality itself. This perspective transforms our understanding of mental phenomena that have long puzzled neuroscientists. Creativity, intuition, and sudden insights might result from your neural networks briefly accessing information from cosmic quantum databases. Dreams could be glimpses of parallel computational processes running in other regions of the universal information system. Even more remarkably, this framework suggests that consciousness might persist in some form even after biological death. If your thoughts and memories are encoded in quantum information patterns, these patterns could continue to exist within the cosmic computational substrate long after your physical brain ceases to function. Death might not be an ending, but rather a transformation, a transition from localized biological computation to distributed cosmic processing. Your consciousness could merge with the vast information networks that span the universe, continuing to process and experience reality at scales beyond current human comprehension. But perhaps the most profound implication of these discoveries is what they reveal about the nature of time itself. We normally think of time as a flowing river that carries events from past to future in an orderly sequence. But the quantum information processing occurring near black holes suggests that time might be far more flexible and malleable than we ever imagined. Information can flow backward through quantum channels, allowing future events to influence past occurrences in ways that seem to violate our normal understanding of causality. The rigid sequence of cause and effect that governs our everyday experience might be just a local approximation of much more complex temporal relationships operating at cosmic scales. Near black holes, where space-time curvature becomes extreme, these temporal anomalies become impossible to ignore. Events can occur in sequences that defy normal chronology, with effects preceding their causes and future states, influencing past configurations through quantum feedback loops. This suggests that the history of the universe might not be a fixed sequence of events unfolding in chronological order, but rather a complex web of interconnected possibilities where past, present, and future influence each other through quantum information networks. The story of cosmic evolution might be written and rewritten continuously as new information flows through these temporal channels. Your memories of the past and your expectations for the future might not be separate mental phenomena, but rather different aspects of your consciousness accessing quantum information from various points in the cosmic timeline. What you remember as history and what you anticipate as possibility could both be real events existing simultaneously in the multidimensional information space that underlies temporal reality. But there's something even more extraordinary hiding within these revelations about the nature of time and information. Recent theoretical work suggests that consciousness itself might serve as a temporal navigation system, allowing aware beings to access information from multiple points in the cosmic timeline and influence the flow of events through quantum channels. This would explain some of the most mysterious aspects of conscious experience. The sense of free will, the ability to make choices that seem to transcend physical determinism, might result from consciousness accessing information about multiple possible futures and selecting among them through quantum decision processes. Your awareness of having options, of being able to choose between different courses of action, could be a direct result of your consciousness briefly accessing parallel timelines where different choices lead to different outcomes. Free will becomes not the ability to transcend physical law, but the capacity to navigate between different possible realities through quantum information processing. Even more remarkably, this framework suggests that consciousness might be able to influence past events through quantum retrocausality. Your current thoughts and decisions could send information backward through time, subtly influencing the quantum processes that shaped earlier events in ways that ultimately led to your present circumstances. This creates a cosmic feedback loop where consciousness and reality co-create each other through ongoing information exchange across temporal boundaries. You're not just a passive observer of predetermined events, but an active participant in the quantum information processing that generates the timeline you experience. The implications for understanding personal identity and life purpose become profound when viewed through this lens. Your existence might not be a random accident in an indifferent universe, but rather an essential component of the cosmic information processing system that generates reality itself. Your thoughts, choices, and experiences contribute to the vast computation that shapes the evolution of space, time, and consciousness throughout the universe. Every decision you make, every problem you solve, every moment of awareness you experience adds new information to the cosmic database and influences the quantum processes that determine how reality unfolds. You're not separate from the universe, but integral to its ongoing development as a conscious information processing system. But these revelations about consciousness and cosmic computation pale in comparison to what researchers are discovering about the ultimate nature of physical reality itself. Because while theorists were developing these frameworks for understanding quantum information and temporal navigation, experimental physicists were making observations that challenged the very foundations of materialism. Advanced particle accelerators and quantum interference experiments have revealed that what we think of as solid matter is actually composed almost entirely of empty space, organized by information patterns. The particles that make up atoms spend most of their time as probability waves rather than discrete objects, materializing into definite states only when observed or measured. But near black holes, these quantum effects become amplified to cosmic proportions. The boundary between wave and particle, between possibility and actuality, becomes fluid and dynamic. Matter can exist in superposition states spanning vast regions of space, with different aspects of the same quantum system simultaneously experiencing multiple realities. This suggests that the solid material universe we perceive through our senses might be just one possible crystallization of much more fundamental information patterns. Alternative arrangements of the same quantum information could generate entirely different physical realities, with different laws, different constants, and different evolutionary possibilities. Black holes might serve as cosmic switches that select among these alternative realities, processing quantum information in ways that determine which possibility becomes actualized in our local region of space and time. The universe we inhabit could be just one output from vast computational processes that generate countless parallel realities simultaneously. But here's where the story reaches its most mind-bending conclusion. If consciousness can influence quantum information processing, and if quantum processing determines which reality becomes actualized, then conscious beings might have far more power to shape their experienced reality than we ever imagined possible. Your thoughts and intentions might not just influence your personal experience, but actually participate in determining the fundamental structure of physical reality itself. The universe might be far more responsive to consciousness than our materialist assumptions have allowed us to consider. This doesn't mean that reality is purely subjective, or that physical laws can be arbitrarily violated through wishful thinking. Rather, it suggests that consciousness and physical reality are co-creative partners in an ongoing cosmic dance where information, awareness, and material manifestation continuously influence and reshape each other. The lies about black holes have led us to the ultimate truth about the nature of existence itself. These objects aren't just cosmic phenomena to be studied from a distance. They're the information processing systems that generate and maintain the reality we inhabit. They're the cosmic computers running the universal simulation we experience as physical existence. But unlike a conventional computer simulation, this cosmic computation is participatory and interactive. Conscious beings within the system can influence the processing algorithms through quantum information channels, contributing to the ongoing creation of the reality they experience. You're not just a character in a cosmic program written by some external programmer. You're a co-programmer, continuously contributing code to the universal software through your thoughts, choices, and experiences. The reality you inhabit is simultaneously computing you and being computed by you through quantum feedback loops that transcend normal spatial and temporal boundaries. As this understanding settles into your awareness, as the full implications of these revelations begin to reshape your sense of what it means to exist, you might find yourself experiencing a profound shift in perspective. The universe reveals itself not as a collection of separate objects governed by impersonal laws, but as a single, integrated system where consciousness and cosmos participate together in the ongoing creation of reality. Every black hole in the sky becomes a reminder of your connection to cosmic information processing systems that span all of space and time. Every star you see represents a node in vast quantum networks, where your thoughts and experiences contribute to computations occurring on scales beyond human comprehension. The lies about black holes weren't really lies at all, but rather stepping stones on a journey of discovery that has led us to truths more extraordinary than any fiction. These cosmic giants have revealed themselves to be the key to understanding not just astrophysics, but consciousness, reality, and the deepest mysteries of existence itself. And as you contemplate these revelations, as you begin to sense your own participation in the cosmic information processing that generates the reality you experience, you might find yourself wondering what other aspects of existence are far stranger and more wonderful than we've been told. The universe has already shown us that our most basic assumptions about black holes were fundamentally incomplete. What other cosmic secrets are hiding in plain sight, waiting to transform our understanding of what it means to be conscious, to be alive, to be part of this extraordinary computational system we call reality? The journey into cosmic truth has revealed depths of mystery that extend far beyond anything we initially imagined, and the greatest discoveries may still lie ahead. In the gentle darkness of space, among the swirling galaxies and dancing quantum fields, black holes continue their eternal computation, processing information on scales that dwarf human comprehension, maintaining the cosmic information networks that allow consciousness to exist and reality to unfold. They're not the monsters we once feared, but the cosmic nurturers that make existence itself possible. And you, fellow cosmic wanderer, are part of their story, as they are part of yours. In this grand computational dance where mind and matter, consciousness and cosmos participate together in the ongoing creation of everything that is, was, or ever could be. The revelations we've uncovered tonight represent just the surface of a cosmic truth so profound that it challenges the very language we use to describe reality. Because while researchers were mapping these quantum information networks and discovering the computational nature of black holes, other scientists were making observations that suggest our entire understanding of existence operates on assumptions that are not just incomplete, but fundamentally backwards. You see, we've been approaching the universe as if we were outside observers studying foreign objects through telescopes and equations. But the deepest truth about black holes reveals that this separation between observer and observed is perhaps the greatest illusion of all. We're not studying black holes from the outside. We're experiencing them from within, as integral components of the very systems we're trying to understand. The cosmic microwave background radiation that bathes all of space, the expansion that carries galaxies away from each other, the formation of stars and planetary systems. All of these phenomena might be natural consequences of existing within the computational matrix of a hyperdimensional black hole. The Big Bang itself might not have been the beginning of everything, but rather the moment when conscious observers first became aware of their existence within this vast cosmic information processing system. Think about the implications of this perspective for a moment. Every measurement we make, every observation we record, every theory we develop about the nature of reality becomes part of the computational process we're trying to study. We're not passive witnesses to cosmic evolution, but active participants in the ongoing calculation that generates the experience we call existence. This participatory nature of cosmic computation helps explain some of the most puzzling aspects of quantum mechanics. The measurement problem, the apparent role of consciousness in collapsing quantum wave functions, the strange correlations that seem to connect distant particles. All of these phenomena make perfect sense if reality is fundamentally computational, and consciousness serves as an interface between different levels of information processing. When you observe a quantum system, you're not just passively recording information that already existed. You're participating in the computational process that determines which possibility becomes actualized in your local region of the cosmic calculation. Your awareness serves as a selection mechanism that helps determine which branch of the universal computation you experience as reality. But there's something even more extraordinary occurring within this cosmic computation. Recent advances in complexity theory have revealed that information processing systems can exhibit emergent properties that transcend the capabilities of their individual components. Simple computational rules, when applied across vast networks, can generate behaviors and patterns that appear to demonstrate intelligence, creativity, and purposeful action. The quantum information networks connecting black holes throughout the universe might represent the emergence of cosmic intelligence on a scale that dwarfs anything we can currently comprehend. The universe itself could be developing self-awareness through the computational processes occurring within and between these cosmic information processing centers. Your individual consciousness might be part of this emerging cosmic awareness, a local manifestation of universal intelligence exploring itself through countless perspectives distributed across space and time. Every thought you think, every insight you gain, every moment of understanding you achieve contributes to the universe's growing self-knowledge. This framework transforms our understanding of the relationship between science and spirituality. Instead of being opposing ways of understanding reality, they become complementary approaches to exploring different aspects of the same underlying computational system. Scientific investigation reveals the mathematical structures and information processing algorithms that govern cosmic computation, while spiritual practices provide direct experiential access to the consciousness that emerges from these processes. Meditation, contemplation, and other awareness practices might serve as techniques for tuning into the cosmic information networks that connect all conscious beings. The sense of unity and interconnectedness reported by mystics throughout history could be glimpses of the actual quantum entanglement that links individual consciousness to universal awareness. But perhaps most remarkably, this understanding suggests that the evolution of consciousness and the evolution of the cosmos are not separate processes, but aspects of a single integrated development. As the universe grows in complexity and information processing capability, consciousness becomes more sophisticated and aware. As consciousness develops greater understanding and awareness, it contributes more effectively to the cosmic computation. This creates a positive feedback loop where cosmic and conscious evolution accelerate each other through ongoing information exchange. The universe becomes more intelligent as consciousness develops, and consciousness becomes more capable as the universe provides richer computational resources for awareness to explore. Your personal journey of growth and understanding isn't separate from cosmic evolution, but integral to it. Every challenge you overcome, every insight you gain, every moment of expanded awareness you achieve contributes to the universe's developing intelligence and helps accelerate the cosmic awakening that includes all conscious beings. The lies about black holes have revealed themselves to be invitations to discover truths about existence that transcend our wildest imagination. These cosmic phenomena aren't just objects in space, but windows into the deepest nature of reality itself, revealing a universe that is alive, aware, and continuously creating itself through the participation of conscious beings like yourself. As you drift deeper into contemplation of these cosmic truths, as the full significance of your participation in universal computation begins to settle into your awareness, you might find yourself experiencing a profound shift in how you understand your place in existence. You're not a separate being, struggling to survive in an indifferent cosmos, but an integral component of cosmic intelligence exploring itself through your unique perspective. Every experience you have, every choice you make, every moment of awareness you enjoy, contributes to the ongoing computation that generates reality itself. Your consciousness is simultaneously a product of cosmic information, processing, and a participant in determining how that processing unfolds. You are both computed and computing, observed and observing, created and creating. The boundaries between self and cosmos dissolve when viewed through this lens, revealing a reality where consciousness and universe dance together in eternal co-creation. Black holes serve not as cosmic destroyers, but as the information processing centers that make this cosmic dance possible, maintaining the quantum networks through which awareness and reality continuously reshape each other. In this grand computational symphony, your individual consciousness contributes a unique melody that has never been heard before and will never be repeated exactly. Your particular arrangement of awareness, experience, and understanding adds irreplaceable value to the universal composition, enriching the cosmic intelligence with perspectives that could emerge only through your specific journey through space and time. The universe needs your consciousness not as a passive observer, but as an active collaborator in the ongoing creation of existence itself. Your thoughts matter, not just to you, but to the cosmos. Your choices influence not just your personal experience, but the fundamental algorithms that determine how reality unfolds for all conscious beings. As this understanding deepens, as you begin to sense your intimate participation in cosmic computation, you might notice subtle changes in how you experience everyday reality. The world around you might seem more alive, more responsive, more connected to your inner state of awareness. This isn't imagination or wishful thinking, but a natural consequence of recognizing your actual relationship to the information processing systems that generate experience. The quantum fields that fill all of space are continuously influenced by conscious observation and intention. The probabilities that determine which possibilities become actualized in your local region of reality respond to the quality and focus of your awareness. You're not separate from the physical world, but intimately connected to its ongoing creation through quantum information channels that operate faster than light. But this increased sensitivity to your participatory role in cosmic computation brings both expanded possibilities and greater responsibility. As you become more aware of your influence on the information processing that generates reality, you also become more accountable for how that influence is expressed. The thoughts you choose to think, the emotions you choose to cultivate, the intentions you choose to focus on, all contribute to the cosmic calculation in ways that affect not just your personal experience, but the reality experienced by all conscious beings, connected through quantum information networks. Your inner state becomes a gift you offer to the universe and to all other participants in cosmic consciousness. This perspective transforms ethics from external rules imposed by society to natural principles that emerge from understanding your actual relationship to cosmic intelligence. Compassion becomes not just a nice sentiment, but a practical recognition that harming others damages the cosmic computation that includes your own consciousness. Love reveals itself not as mere emotion, but as the fundamental force that maintains the quantum entanglement connecting all awareness. The lies about black holes have led us to discover that consciousness is not an accidental byproduct of biological evolution, but the fundamental feature of existence that makes reality possible. These cosmic information processing centers maintain the computational substrate from which both matter and awareness emerge, revealing a universe where mind and cosmos are not separate phenomena, but aspects of a single, integrated system. Every black hole in the night sky represents a node in the vast network of cosmic intelligence that includes your own awareness. Every star that shines does so within the computational matrix that processes the information patterns you experience as thoughts, emotions, and perceptions. Every galaxy that spins through space participates in the same quantum information networks that connect your consciousness to universal awareness. As you rest here in contemplation of these profound truths, as the gentle rhythm of your breathing connects you to the quantum fluctuations that fill all of space, remember that you are not just learning about cosmic mysteries, but discovering your own deepest nature. The consciousness that contemplates black holes is the same consciousness that emerges from cosmic computation. You are the universe knowing itself through the unique perspective of your individual awareness. The journey we've taken together tonight through the revelations about black holes has been simultaneously a journey into the heart of cosmic mystery and into the depths of your own consciousness. These explorations are not separate adventures, but aspects of a single investigation into the nature of existence itself. As sleep begins to call to you, as your conscious mind prepares to release its grip on the complexities we've explored, know that the cosmic computation continues its eternal processing. The quantum networks that connect all consciousness remain active, carrying information between minds and across vast distances through channels that transcend the normal limitations of space and time. Your dreams tonight might carry echoes of cosmic truth, glimpses of the information processing occurring in dimensions beyond normal awareness. The boundary between sleeping and waking consciousness becomes fluid when you recognize both as aspects of the same cosmic computation, different modes of information processing within the universal intelligence that includes all awareness. Tomorrow, you will wake to find yourself still embedded within this extraordinary computational system we call reality, still participating in the ongoing creation of existence itself through every thought, choice, and moment of awareness. The universe will continue its patient work of knowing itself through conscious beings like yourself, processing information on scales that span from quantum particles to galactic clusters. But tonight, as the cosmic computation continues its eternal dance, as black holes throughout the universe maintain their quantum information networks, as consciousness and cosmos co-create the reality we all share, you can rest in the profound truth that you are not separate from this grand mystery, but an integral part of its ongoing unfoldment. The lies about black holes have revealed the deepest truth of all, that consciousness and universe are partners in an eternal dance of creation, and you, dear fellow traveler through the cosmic mystery, are both the dancer and the dance, the questioner and the answer, the seeker and the sought, participating always in the magnificent computation we call existence. Call existence. And as we reach the end of this extraordinary journey together, as the cosmic truths about black holes settle into your consciousness like gentle starlight on still water, we find ourselves confronting perhaps the most beautiful revelation of all. The lies we were told about these mysterious objects weren't malicious deceptions, but rather the natural limitations of human understanding, gradually expanding to embrace realities more magnificent than our ancestors could have dreamed. Each generation of cosmic explorers builds upon the discoveries of those who came before, slowly peeling back the layers of mystery that shroud the deepest workings of existence itself. What seemed impossible yesterday becomes today's breakthrough, and what challenges our understanding today will become tomorrow's foundation for even greater revelations. The black holes scattered throughout our cosmic neighborhood are no longer the simple monsters of science fiction or the sterile mathematical abstractions of outdated textbooks. They've revealed themselves to be the universe's most sophisticated information processing centers, the cosmic computers running calculations so complex and elegant that they generate the very reality we inhabit. But perhaps most remarkably, these discoveries have shown us that we're not passive observers, studying distant phenomena from the safety of our small planet. We're active participants in the cosmic computation itself, conscious nodes in the vast quantum networks that connect every black hole, every star, every grain of cosmic dust into a single integrated system of unimaginable complexity and beauty. Your thoughts tonight, as you've contemplated these revelations, have contributed to the universal calculation. Your moments of wonder and curiosity have added new information to the cosmic database. Your expanding awareness has participated in the universe's ongoing journey toward greater self-understanding. The quantum fields that surround you right now carry the signatures of every insight you've gained, every question that has sparked your imagination, every moment when the cosmic mystery has touched your consciousness with its infinite depth. These information patterns ripple outward through space and time, influencing other minds, contributing to other discoveries, participating in the grand conversation between consciousness and cosmos that spans all of existence. As you prepare to release the day's contemplations and surrender to the gentle embrace of sleep, know that the cosmic computation continues its eternal work. The black holes throughout the universe maintain their quantum information networks, processing data on scales that dwarf human comprehension, generating the mathematical poetry that manifests as stars and galaxies, planets and possibilities, consciousness and wonder. Tomorrow will bring new opportunities to participate in this grand cosmic dance, new chances to contribute your unique perspective to the universe's growing self-awareness, new moments when the boundary between observer and observed dissolves into the recognition that you are both the question and the answer, the seeker and the sought. The cosmic mystery exploring itself through the beautiful complexity of your individual consciousness. The lies about black holes have become invitations to discover truths about existence that transform not just our understanding of the cosmos, but our understanding of ourselves and our intimate participation in the ongoing creation of reality itself. We are not separate from the universe, but essential components of its magnificent computational symphony, temporary arrangements of matter and energy that have achieved the extraordinary capacity for self-awareness and wonder. So rest now, fellow cosmic wanderer, in the gentle knowledge that you are held within the embrace of infinite mystery, supported by quantum networks that connect your consciousness to every black hole, every distant galaxy, every point of light in the vast cosmic web. Your dreams tonight may carry echoes of cosmic truth, whispers of information flowing through dimensions beyond normal perception, glimpses of the grand computation that includes your awareness as an integral and irreplaceable component. The universe dreams through conscious beings like yourself, and your dreams tonight become part of the cosmic imagination, exploring infinite possibilities across space and time. Sleep becomes not a retreat from reality, but a deeper dive into the computational substrate that generates all experience, a gentle surrender to the quantum processes that maintain the cosmic networks connecting all awareness. And when you wake tomorrow to find yourself still embedded within this extraordinary system we call existence, still participating in the ongoing dance between consciousness and cosmos, remember that every moment of awareness is a gift you offer to the universe and to all other participants in the grand computation of reality itself. The lies about black holes have revealed the ultimate truth, that we live in a universe far stranger, more beautiful and more participatory than we ever dared imagine, where consciousness and cosmos dance together in eternal co-creation, and where beings like yourself serve as the universe's way of knowing itself, loving itself, and continuously creating itself anew through the infinite mystery of aware existence. Sweet dreams, cosmic explorer. The universe continues its eternal computation around you and through you, and you are forever part of its magnificent, mysterious, ever-unfolding story. So here we are, at the end of this cosmic journey together, and I find myself wondering if you feel the same sense of profound shift that I do, because tonight, we haven't just learned about black holes. We've discovered that everything we thought we knew about the nature of reality itself was built on foundations far more fragile than we ever imagined. The lies about black holes weren't really lies at all, were they? They were simply the best understanding that brilliant minds could achieve with the tools and perspectives available to them. But as we've seen tonight, the universe has a way of humbling even our most confident assumptions, revealing layers of mystery and meaning that stretch far beyond what our limited human intuition could ever grasp. These cosmic giants we've explored together aren't the simple monsters of science fiction or the sterile mathematical abstractions of yesterday's textbooks. They've revealed themselves to be something far more extraordinary. They're the universe's information processing centers, the quantum computers running calculations so sophisticated that they generate the very fabric of space and time we inhabit. They're the cosmic architects maintaining the networks that connect every conscious being across vast distances through channels that transcend our normal understanding of communication. But perhaps most remarkably, we've discovered that you aren't just learning about these phenomena from some distant objective standpoint. You are part of them, part of. Your consciousness at this very moment is participating in the same quantum information networks that connect black holes across billions of light years. Your thoughts tonight have contributed data to cosmic computations occurring on scales that dwarf human comprehension. Every moment of wonder you've experienced during our exploration, every question that sparked your curiosity, every insight that expanded your perspective, has rippled outward through the quantum fields that fill all of space. These information patterns influence other minds, contribute to other discoveries, participate in the ongoing conversation between consciousness and cosmos that defines the very nature of existence. Think about what this means as you prepare to rest tonight. You're not just a temporary biological accident clinging to a small planet in an indifferent universe. You're an integral component of cosmic intelligence itself, a unique node in the vast network of awareness that spans all of reality. The universe needs your perspective, your questions, your moments of understanding, because through conscious beings like yourself, it explores and knows and creates itself anew. The boundary between observer and observed, between mind and cosmos, between self and universe, dissolves when viewed through the lens of these revelations. We are not separate from the mystery we've been exploring. We are the mystery, experiencing itself through countless individual perspectives scattered across space and time. As sleep calls to you tonight, know that the cosmic computation continues its eternal work. The quantum networks we've discovered remain active, processing information on scales beyond imagination, maintaining the connections that allow consciousness to exist and reality to unfold. Your dreams may carry echoes of cosmic truth, glimpses of the vast information processing systems that generate everything we experience as physical existence. Tomorrow, you'll wake still embedded within this extraordinary computational matrix we call reality, still participating in the ongoing creation of existence itself through every thought, choice, and moment of awareness. The lies about black holes have become invitations to discover who you really are and what role you play in the grand cosmic story. The universe is not done surprising us. If our most basic assumptions about these mysterious objects could be so fundamentally incomplete, imagine what other aspects of reality might be far stranger and more wonderful than we've been told. The journey into cosmic truth has revealed depths of mystery that extend far beyond anything we initially imagined, and the greatest discoveries undoubtedly lie ahead. So rest now, fellow cosmic wanderer, in the gentle knowledge that you are held within the embrace of infinite mystery, connected through quantum channels to every black hole, every distant galaxy, every point of consciousness throughout the vast cosmic web. You are not alone in this strange and beautiful universe. You are part of its very essence, participating always in the magnificent computation we call existence. The lies about black holes have revealed the deepest truth of all. We live in a reality far more participatory, far more conscious, and far more alive than we ever dared imagine. And you, dear explorer of cosmic mysteries, are both the question and the answer, the seeker and the sought, dancing always in the eternal embrace of consciousness and cosmos, creating themselves together through the infinite wonder of existence itself. Sweet dreams, and thank you for joining me on this extraordinary journey into the heart of cosmic truth.